I'm going to start with triangle. So you'll have to study. You can see the topics here, the checklist of the chapters, like similar figures and similar triangles. How you can relate that two triangle figures are similar to each other. Then the criteria of similarity of triangles, area of similar triangles, Pythagoras theorem, and its converts. I was actually waiting that three of them are still not joined. I'll wait for last 1 more minute. Okay, it's already 4 minutes have gone, so let me start. Okay, yeah. So today's chapter is triangle, and in triangle we will be covering 4 different topics like similar figures and similar triangles, criteria for similarity of triangles, area of similar triangles, Pythagoras theorem and its converse. Okay, so let's see topic 1. Okay, now similar figures and similar triangles. What do you mean by similar figure? Okay, from the word itself, similar figure means the figures that look similar to each other. Okay, like if I ask you, okay, if I ask you that square is similar to triangle, it's no. Okay, if I ask you a square is similar to square, yeah, similar. Okay, in spite of the size. Okay, the size may differ. Okay, but the shape, if the shape is same, then these figures are similar. Okay, so have you understood about similarity? This is the concept about similarity. That now let's see similar polynomial. Okay, similar polynomial. Sorry, polygon. Okay, polygons are the two-dimensional figure. Okay, with finite sides. So polygon may be a triangle, a square, a pentagon, a hexagon. Okay, so when we are studying about the similarity of polygon, the polygon we will be taking of same sides. Okay, if they're having different sides, then you cannot just, they are not similar, they are two different triangles, different polygons. So this, how you will check that two polygons of same sides are similar? There are 2 points that you have to check, that their corresponding angles are equal. Corresponding angles are equal. Okay, and the second criteria that should be corresponding sides are in same ratio. Corresponding sides in same ratio. That means if you see a triangle, okay, 2 triangles, if you want to see that these 2 triangles are similar or not, then you have to check that the area and then that their angles are equal, and also that the sides are in the same ratio, like it is A, B, C, D, E, F. That means AB by DE is equal to BC by EF is equal to AC by DF. Okay, so the ratio of the sides are equal. Okay, if these 2 conditions exist, that means the polygons are similar to one another. Okay, I'm not asking about equality, the similarity. Okay, the 2 of the figures are similar. Okay, now whenever let's just see an example here. Example number 2. Okay, state whether the given quadrilateral are similar or not. Okay, how can you say that these 2 quadrilaterals are similar? Okay, now we'll check the ratio, that are they, because angles are, first we will check the ratio and angles. From angles you can directly say the angles are not equal, because there is a right angle triangle you can say in ABCD, and there is little slightly tilted. Okay, so the angle doesn't look same, but just let's see the ratio. So PQ by AB is 2.5 by 4. The ratio are also the ratio are same, but the angles are not same. That means this is not a similar figure. Okay, both the figures are different. Okay, so in this way you can check the similarity between the figures. The 2 figures are similar or not by checking their angles and by checking their ratio of sides. Okay, now similar triangles. As we are going to study in detail about the triangles, so we are just checking about how you can say that 2 given triangles are similar to each other or not. Okay, so basically what is a triangle? Triangle is a figure which has 3 sides. Okay, it has 3 sides and it has 3 angles also. Okay, there are 3 angles and 3 sides. So when you are checking that 2 triangles are similar or not, that means you have to see that their angles, all the corresponding angles are equal or not in both the triangles, and also you have to check the corresponding sides are proportional or not. Okay, if these 2 conditions exist, that means they both the triangles are similar to each other. Okay, yeah, Shazan, what is your issue?
Ma'am, I didn't get it. That's why I just must.
About the similarity of triangle?
Yes, how to find this.
Okay, I'll show you with the figure and then you will understand. Okay, 2 means if both the triangles ABC, triangle ABC and triangle DEF, for them to be similar, the condition is that angle A should be equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. And the side should be, the corresponding side should be in ratio. Okay, that means AB by BE is equal to BC by EF is equal to AC by DF. Okay, now understood, Shazan? what I mean to say about the two conditions. Okay, you can see here it's already written that their corresponding angles are equal, their corresponding sides are proportional. Okay, these 2 points. Okay, they are understood. So here this is the example. In fact, you can see that in triangle ABC, in triangle PQR. Okay, angle A is equal to angle P.
Yes,
Angle
ma'am.
B.
All the angles should be same.
Yeah, and their side should be in a ratio. That it means AB, this AB should be proportional by PQ. This AB by PQ is equal to BC by QR is equal to AC by PR. Okay. Now, then if this both the condition exists, that means triangle ABC is similar to triangle PQR. Understood? And the converse, that if the triangle is similar, that means both the condition exist. Okay. The converse is also there. Okay. That if both the triangles are similar, that means their angles are equal and their ratio of the sides are equal. Okay. Now, symbolic representation of two similar triangles. Now, symbolic representation here means that
Mom, so in a triangle, if one of the conditions is true, then the other will also be true.
no, if both are true, then the triangles are similar. Okay. Converse means if it is said that the triangles are similar, if both the triangles are similar, that means the angle will also be equal and the ratios will also be equal. That is AB by PQ is equal to the sides. AB by PQ, BC by QR, AC by PR will be equal. Okay, understood?
Yes, ma'am.
So here, yeah. Okay, symbolic representation means see. You can see two triangles here. Now, first triangle you are representing by ABC. Okay, then the second triangle is DEF. Okay, because angle A is equal to angle D. You can see in the figure, angle A is equal to angle D, and angle B is equal to angle E, angle C is equal to angle F. Okay, now if angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F, then these triangles, you are going to write this, that triangle ABC, you can write that a triangle ABC is similar to DEF, also from the sides also proportional, but you cannot write that triangle ABC is similar to triangle EFD. Okay, you're going to mention the same angles with the same angle. Okay, like angle A is equal to angle D. Okay, you see here angle A is equal to angle D. So when you are mentioning the triangle, you are going in the same clockwise or same anti-clockwise direction. You cannot switch it. Okay, like you're writing ABC. If you're going ABC, then you have to go here also DEF. Okay, you cannot write EFD. Okay, remember that when you are representing the triangle and you are writing for like they are similar or that. Because if you are comparing ABC, if you're writing ABC similar to EFD, it is wrong. Because angle E is not equal to angle A. Angle E is equal to angle B. So angle E should be corresponding to angle A. Okay. And if corresponding angles of two triangles are equal, then they are known as equilateral triangle that you already know. Okay. Wait. What is the issue here? Okay, let's check one question on the basis of the similarity of triangle. Okay, that how can you say that both the triangles are similar or not? Just a minute. Okay, just a simple question. Now here it is telling you that in the question that triangle ABC is similar to triangle PQR. Okay, and it is given that AB is equal to 6.5 centimeter, PQ is equal to 10.4 centimeter, and parameter of the triangle is given. Find the parameter of the other triangle. The parameter of one triangle is given. It is asking you the parameter of another triangle. Let us copy this and just do the question. Okay. Now, since triangle both are similar, so let's see both the triangles here. One is ABC and one is PQR. Now it is PQR. Now AB is given to you 6.5 centimeter, PQ is given to you 10.4 centimeter, and parameter is given to you ABC. Okay. Now since it is similar triangle, so we already know that AB will be equal to PQ is equal to BC by QR is equal to AC. AC will be equal to PR. Okay, am I right? Because they are similar. It is already given to you that they both the figures are similar. So if they're similar, so this condition exists. Now we know from the given value that AB by PQ is 6.5 by 10.4. Okay, AB by PQ. So it can be written as 65 by 104. Okay. Now parameter. The parameter of ABC is given. That is, parameter means AB plus BC plus CA is equal to 60. Now, if you will see from here, from this equation, if you write equation 1, so from equation 1, okay, you can see that, we don't write from equation 1 here. See, from here, AB by PQ is equal to 65.05. So you can write as AB is equal to 65 by 104 multiplied by PQ. You can write this. Similarly, you can write for other sides also, okay, because their ratio are same. So BC can be written as 65 by 104 multiplied by QR. And
Ma'am, I'm not getting this.
okay, I will write it again.
Can you do it just once again?
Great. Okay, now this time, see. Okay, now it is given to you in the triangle that AB is similar to another PQR. That means this will tell you that AB by PQ is equal to BC, BC by QR is equal to AC by PR. Am I right, everybody? If they are both the triangles are similar, that means this ratio will be same. Okay, and it is given to here that AB by PQ. The values are given of AP and PQ. It is 6.5 by 10.4. So it can be written as 65 by 104. I'm just removing the points because, okay, till here, everybody clear? Okay, now you can see all the ratios are equal. So AB value can be written from here. It implies that AB value is equal to 65 by 104 by PQ. Okay, this is P. Okay, similarly, you can write value of BC. BC is equal to 65 by 104 into QR, and CA. CA can be written as 65.104 into RP. Okay, so now one more thing is given to you, that is the parameter of triangle ABC 60 centimeter. What do you mean by parameter? Parameter means addition of all the sides. Okay, CA is equal to 60. Now AB, you know that AB can be written as 65 by 104 PQ, BC can be written as 65 by 104 QR, and CA can be written as 65 by 104 RP. So we can take 65 by 104 is bracket PQ plus QR plus RP, okay, is equal to 60. So from here you can get the parameter of PQ plus QR plus RP. This will be equal to 60 multiplied by 104 by 65. Am I right? Till here, everybody clear that how it is done? Okay. Now this is the final. Okay. So from here you can just divide and get the value. Okay. So it is 96 centimeter. Okay. The parameter of that is triangle PQR is equal to 96 centimeter parameter. Okay. So this was a simple thing that by using the ratio, it was because the condition was given that triangle ABC is similar to triangle PQR. So this condition existed. Okay. Now this was just simple introduction of that, how you can compare the similarity of a triangle and what this means, that how can you say that two triangles are similar. Okay, so two triangles are similar, that means the angles are similar and the ratio, the corresponding ratio are proportional. Okay, now the main things start from here, the main theorem, that is basic proportionality theorem, BPT. Okay, BPT means what? Okay, what does the BPT say? Now the basic proportionality theorem, let's see what does the BPT say. That is that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. Now what this means, this is also known as the Thales theorem. Okay, now for example, this is your triangle A, B, C. Okay, now a line is drawn between this, that it is, you can point as D and F. Okay, now if this line is drawn parallel to the line BC, then this line divides the other two sides in a ratio. That means that it is telling that you have to prove that AD by DB is equal to AF by FC. Okay, understood what this theorem is saying, that if DF is parallel to BC in this triangle, then you have to prove that AD by DB is equal to AF by FC. Okay, now we need to prove this. Okay, now let's see how can you prove. Now what you have to do, some construction will be needed to prove. That is, we are going to join. Okay, now we are going to join this. Okay, and we are going. Yeah.
Can you fill the question once again?
It is not a question, it is a theorem. Okay, basic proportionality theorem, that is BPT, theorem 1. What does theorem say? You can directly use the theorem, but for directly using also you know how it is proved and what does the theorem say. Okay, so what the theorem is saying, that if a line is drawn, you can see here, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. That is, if you draw a line parallel to the center, that is BC, we are drawing a line parallel to BC, that is DE. Okay, in this triangle ABC, then it says that you have to prove that AD by DB is equal to AE by EC. Okay, to prove that AD by DB is equal to AE by EC. Now, how we are going to prove? Okay, this is a Thales theorem. That means if DF is parallel to BC, then this condition exists. Okay, now we are going to draw a perpendicular from F on AB, and we are going to mark it as F. And we are going to draw a parallel line DG from D point. Okay, understood? Now, how we can prove that? Okay, now if you see the area of the triangle, if you see the area of a triangle, which triangle I'm asking? If area of the triangle this and area of the triangle this, and then we are going to see area of triangle this and this. Okay, so if you see the area first, we are going to see the area of the triangle. What is the area of the triangle? Half base into height. Yeah. So if you see the ratio of area of triangle ADF, okay, ADF, then it will be half base into height. Half base will be your DF into height will be, sorry, it is F is here, so it is E, okay, into EF. Okay, now if you take the ratio of the area, now the next triangle that we are taking, that is BDE. Okay, BDE, again half base into height, that is base is again the same and height is, sorry, base is BD, height is same. Okay, so what you get, that is AD by DD. Okay, AD by DD. Okay, till here everybody understood? See, we are taking this time. Okay, this portion only, this blue portion. Okay, now here I'm just drawing that much, that is A, D, and this is E, and this is B. Okay, and from here we have drawn a perpendicular line F. Okay, now one triangle is ADE, and one triangle that is we are taking, that is ABE. Okay, yeah. Now that if you see the ratio of the triangle area, that is area of triangle ADE, what it will be, half base into height. Half base will be AD and height will be EF. Okay, similarly for triangle BDE also, base will be this and height will be same this. Okay, now you can see half can be cancelled from half and EF will be cancelled for EF. So you got that area of the triangle is in the ratio AD by DB. First thing. Okay, the first you can say first equation that you got here. Okay, now similarly we are going to pick the another part, another side of the triangle, that is this side. Okay, that is this side. Okay, where it is C, E, again D is there and A is there. Here another perpendicular line is drawn from DA, that is F. Okay, this triangle. Now if you see the area, we will compare the area of these two triangles. Again, it can be written that area of triangle ABE, okay, by area of triangle CDCE. Okay, so how you can write? Again, half base into height, half base will be AE and height will be DG. Okay, again half EC multiplied by DG. Okay, so again you can see you can cancel DG in half, so you got AE by EC. Okay, second. Now since same base, okay, if you see both the triangles here, these two triangles, this one and this triangle, okay, that is BDE and CDE. Okay, if you take both these triangles, that is area of triangle BD, what is that? BDE. BDE is equal to area of triangle CDE. CDE. Why they are equal? Because area of triangle is half base into height. So you can see the base is same, DE, and the height will also same because they are drawn between two perpendicular lines. Okay, so since the area is same, from this if you will conclude all the three equations, this is equation number 3. If you conclude all the three equations, you get AD by DB is equal to AE by EC. Okay, everybody got it? Or you can just see here. Okay, if you are still facing problem, you can see a clear figure. Okay, see, first we have taken a triangle ADE and next triangle is BDE. Okay, both their areas, we have taken the ratio of both their areas. Okay, then we have chosen ADE by DEC. Okay, and we know that the area of triangle BDE is equal to CDE, since the base is same, height is same. Okay, and then all the three equations, when we are equating, then we got that AD by DB is equal to AE by BC. Okay, hence proved. And what we got the result, that if in a triangle, if you draw a parallel line from another side of a triangle, that is DE, then their sides are in a ratio, that is AD by DB is equal to AE by EF. Okay, you can use this result to solve many questions. Okay, you can directly say that from BPT, from Thales theorem. Okay, and you can use the condition. Okay, now let's see some means now till now we have just compared the value of AD by DB and is equal to AE by EF. Okay, the means you can extend this theorem and you can see you can prove that AB, the whole line, whole triangle side, AB by DB is equal to AC by EC. Okay, and how you're going to do in the same that the value that we got in the last theorem, the equation number 4 that we got, that is AD by DB. We got AD by DB. Okay, this is the equation number 4 from the till now what we have proved. We're just going to add 1 on both the sides, on the both the side of the equal to. Okay, so you got AB by DB is equal to AC by EC. Okay, that's it, and you can prove this condition also. Anybody any doubt in BPT theorem? BPT, if it is clear, then let's see the converse of BPT, the converse of basic proportionality theorem. Now, what does the converse say? That if a line divides any two sides of a triangle in the same ratio, okay, if the line is dividing the triangle in the same ratio, then the line must be parallel to third side. That means it is telling you that if AD by DB is equal to AE by EC, then prove that DE by DE and BC are perpendicular. Okay, just the opposite that we did till now. Okay, so how can you do that? See, it is asking us to prove that DE is perpendicular to BC. So let's assume that DE is not perpendicular to BC. That means let's draw a line DF that is perpendicular to AC. Okay, so DF is perpendicular. Okay, now let's see if DF is perpendicular. So from BPT, what we got from BPT, what is there? From BPT, it is clear that from BPT theorem that AD by DB, this AD by DB is equal to AF by FC. See, if DF is perpendicular to BC, that means from BPT, okay, so from BPT, what we got that AD by DB is equal to AF by FC. Okay, because this is the thing that Pierce states. Okay, so this here we got. Okay, and it is given to us in the starting only that AD by DB is equal to AE by EC, equation number 1. This particular thing is given to you in the question. You can see if a line divides any two sides of a triangle the same ratio, then the line must be parallel to the third side. The same ratio, it is already given that AD by DB is equal to AE by EC. This one thing is given. And if we are assuming that we are drawing in a triangle ABC, this is DE, we are drawing this thing parallel. Okay, we are assuming that D is not parallel. We are drawing DF as a perpendicular. Okay, so not perpendicular, a parallel line. Okay, we are drawing DF as a parallel to BC. Then from BPT, or you can say from Thayer's theorem, we got AD by DB is equal to AF by FC. Okay, now from first and second, what you can conclude? See the first and second. First and second, if you conclude that AD by DB are same. So that means AE by EC is equal to AF by FC. You conclude, then we get that AE by AC is equal to AF by FC. Okay, we got this. Now, if we are going to, now what we have to prove? See, we got AE by AC is equal to AF by FC. Now we have to conclude that both are equal. That is, this F is similar to E point. Okay, now let's see what we are going to do. We are going to add 1. Okay, on both sides. Okay, so what we will get? That is AE plus AC by AC is equal to AF plus FC by FC. Now, AE plus AC is what? AE plus AC is complete AC. Okay, so we got AC by EC. Okay, so from this, what we got? This is the side that I got. AE by EC. Wait, I did here wrong. AE by AC, and here the calculation went wrong. Okay, just wait. Nobody reminded me. Okay, now what we got from the result? That this is the third one. So what do you have got? See, AE by EC. Nobody reminded that I'm writing wrong. You can see AD and this is equal to AE by EC. So AE by EC is equal to AF by FC. Okay, this is the main thing. Okay. Now if I'm going to add AE by EC plus 1 is equal to AF by FC plus 1. Okay, now EC, AE plus EC by EC is equal to AF plus FC by FC. Now, AE plus EC, what you get? AE by AE plus EC, the whole side, AC, you got AC. And on the second side also, AF plus FC. AF plus FC also you got AC. Okay. So what we have got, that AC by EC is equal to AC by FC. You can cancel AC, AC. So at the end you got EC is equal to FC. So what is EC and FC? EC is equal to FC. That means E and C coincides. Okay. If how can EC and FC be same? That means E and F are same point. Okay. So E and F are same point. Same point. Okay. Hence DE is also parallel. Okay. DE is also parallel to BC. Okay. Understood? Anybody any doubt? Is there any doubt in this? So shall we start the questions based on the converse of the BPT theorem and the BPT theorem? Okay. So, okay. Now, before we start the problem, you should also remember the midpoint theorem and the angle bisector theorem. The midpoint theorem is the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and half of it. Okay, that means if a line is joining the midpoint of any two sides of a triangle, okay, is parallel to the midpoint. This will be the midpoint, just telling you. Okay, and then if it is joining, then this is half of like it is DE, then DE half DE is equal to half of BC. Okay. So this is one of the midpoint theorem you should remember. And angle bisector theorem, that is the internal bisector of an angle of a triangle, divides the opposite sides into segments that are proportional to the other two sides of a triangle. Okay. Now, whenever we are using BPT theorem to solve our problem, they will be
What's the angle bisector theorem?
Angle bisector theorem is the internal bisector. Like, see, if this is a triangle, okay, this is the this line is bisecting this angle. Okay, it is the internal bisector of an angle of a triangle divides the opposite side in two segments. This particular line, this angle bisector, is dividing this line in two segments. One is this segment and one is another is this segment. Okay, that are proportional to the other two sides of the triangle. Okay, that means this is proportional to the other two sides of the triangle. Understood? In proportion. Now, problem based on BPT and its converse. Okay, there will be two types of problem when you are using BPT or its converse. That is, one is you have to prove some other result, or the second type of problem that you have to get a final result. Like some values are given and you have to get the exact value of that value. Okay. Now let's see example 6. That in triangle ABC, points P and Q are on CA and CD. Okay, respectively, such that CA, the value of CA is given to you. CA, CP, and CB also is given. CQ. Okay, all the four values are given to you, and it is also given is it is asking you that is PQ parallel to AB. Now, what will be the condition that PQ is parallel to AB? If you see, then it is asking you the converse of BPT. Okay, in the converse of BPT, if the ratios are similar, that means the both, that is QP will be parallel to BP. So we have to see that if the ratios are similar of the sides, then this is proof. Okay, that is PQ is parallel to AB. Okay, now if you see here, that is CQ by CB. The values of CQ by CB is given. It is not given CQ by QB. From there only we'll take out QB. Okay, so if you see the ratio of CQ by CB, it is 25 by 30, 5 by 6. And similarly, if you see the ratio of CP by CA, it is 10 by 16. Okay, it is again 5 by 8. Okay, both the ratios are not same. If their ratio, let's see about the CQ by CB is not equal to CP by CA. Now, if you are subtracting 1, okay, because we need to find the ratio of CQ by QB. Okay, from the BPT theorem, we need ratio of CQ by QB, and we have the value of CQ by CB. So we are subtracting 1 on both the sides. So what we got? Again, if see this result, okay, if CB by CQ is not equal to CA by CP, then this will then QB by CQ will also be not equal to PA by CP. That means PQ is not parallel to AB. Okay, because the ratios are not same. The ratios are not same. That means they are not parallel also. Okay. Example number 7. If D and E are points on the respective sides AB and AC of a triangle ABC, such that here also your sides are given. Okay, but here a value of AD is given, BD is given, AE is given, and EC is given. Now you have to prove BE is parallel to BC. Very simple. You need to find out the ratio of AD by DB is equal to AE by EC. So what will be the ratio? It will be 6 by 9. You have to prove. Okay, so 6 by 9, and here it is 8 by 12. You have to take out individually, okay, just not like here. Okay, so what it will be? So ratios are equal, 2 by 3, 2 by 3. Okay, since the ratios are equal, that means DE is parallel to BC. Understood? Any doubt, anybody, in the questions or in the theorem? If the theorems are clear, you can directly do the questions also. Okay, now question number 8. In the figure of triangle ABC, DE is parallel to AC. Okay, if DE is parallel to, it is telling you that DE is parallel to AC. If DC is parallel to AP, where points P lies on BC, prove that prove that DE by EC is equal to BC by CP. Okay, this last question we are going to do. Okay, now it is given to you in the question that DE is parallel to AC. If DE is parallel to AC, Rudoniel, can you tell me what will be the condition from BPT? From BPT. Okay, if DE is parallel to AC, Rudoniel, are you there?
Yes.
Yeah. So can you tell me if DE is parallel to AC, what will be the condition from BPT? Which two sides will be in proportion? See, it is talking you about this particular triangle. Okay, and this is parallel to this. So that means that means AE. Okay, that means BE by EC will be equal to AD by BA. Okay, everybody. If this is parallel to this line, that means this by this is equal to this by this. Okay, any doubt? DE by EC is equal to AD by DA. Okay, and again, it is telling you that BC is parallel to AB. BC is parallel to AP. Okay, if BC is parallel to AB, then again, what we got? Equation number 1, you can mark. It will be AC by CP. AC by CP is equal to BD by DA. Okay, BD by DA.
How will it be equal AC by CP? How will it be equal to BD by DA?
AC by CP is equal to BD by DA because DC is parallel to AB. Okay, Satya, the DC, this figure is see from the theorem. One time this DC is parallel to AB. Okay, and in the another it is telling you that this is parallel to this. Understood? Now, if BD is parallel to AC, then what it will be there? That BE by EC is equal to AD by DA. Okay, and in the next it will be if DC is parallel to AP, then BC. Okay, BC. Sorry, it will be BC by CP. Yeah, it will be BC by CP, and this here it will be BD by DA. With DA, you can write DA. That will not confuse DA. Okay. Now you can see here that AD and this is second. Okay. BD and this BD by DA. Yeah, BD by DA. So from equation first and second, okay, you can see that this side is common in both. When you are taking the triangle BAC and when you are taking a triangle BAP, in both the triangles, this BA is common. You can see BD by DA and BD by DA. So from both the equation, what you got? That BE by EC is equal to BC by CP. Okay, everybody. Okay, so this is the thing that you are asking you, that BE by EC is equal to BC by CP. So here you have proof. Okay, everybody. Any doubt? When you will draw this figure clearly, then you'll get it. Okay, that there are two things it is given. One is DE is parallel to EC and another is AC is parallel to AD. From there, two times you are applying the theorem BPT, and then you got two equations. Okay, one equation is this. Okay, from as DE is parallel to AC, and since DC is parallel to this, you got the second equation, and from both the equation we have proved that it's parallel to CP. Okay, so I'm ending the class here. It's almost time. Okay, and we'll see the 2-3 more questions in the next class, and we'll revise there also the theorem. Okay, so let's end the class here only, and from next class I will start the